Welcome to the HeatWise residential tutorial. Uh, in this one, I will not be going over some of the really basic preliminary steps that were covered in the commercial project tutorial. So if you need to see some of the preliminary steps on how to get set up with HeatWise, you can watch the first few minutes of that video. So for this one, we'll just start from the main project dashboard, and what we'll do is hit Create Project and give it a title. So for this one, I will call it My House. And instead of selecting commercial building, we'll select house for this one. You start out your project on the guide page, just like with a commercial project, and everything is the same. And I will go over some of the basics here that will be repeated from the commercial building tutorial. So if you've seen that, you could skip these next 2 minutes. So first thing is in the top right corner, you've got a few buttons here. The first one is for your basic sign out and account settings. The second one is for sending feedback. This is the button you can use to send feedback to the development team for features that you'd like to see or issues that you encountered in the software. And the third button is the Get Help button, so you can request help from the development team if you get stuck anywhere, or if you don't know how to proceed. This will send an email to the team and they will contact you about your issue. The other things to note here are in the top left corner, you have your All Projects button to return to your projects dashboard. And in this projects dashboard, you'll see the projects that you've created as well as ones that have been shared with you. So far, there have been none shared with me yet, but if somebody were to share a project with me, it would show up right here. This also shows you who your projects have been shared with and whether anybody is currently editing them. So returning to the project that we just created, the last two items are down at the bottom left here, your settings. In your settings, you have two sections. There's your general, where you can rename your project, export your project, or delete the project. And you also have your sharing. So this is for sharing your project with a coworker or friend. You can click Add User and you enter their email address. It will send them an email notifying them that a project has been shared with them. So if we go back to our guide page, the last item is the Quick Help. So opening up the Quick Help pop-up will show you lots of information about how to use HeatWise and specifically how to use the various features that are on your page. So on this one, we are on the main project guide page. So what you can see are just is a basic description of how to use the residential load calculation app. But if you were to go to a different tab, for example, if we went to walls, you'll see that we have a completely different Quick Help pop-up. At any point, that can be exited out of, and then you click Quick Help again to pop it back up, and it will be there throughout the entirety of your project. So it's a great tool to use when you don't know what inputs to use or what certain inputs mean or how to interpret the outputs. The Quick Help is a good resource. So now we can get started with building our residential project. So you can see the project guide has just two steps here. There's build house and then run your calculations. So starting with the build house tab on the left here, you can see that this is split into a few sections. First we have our location, and then the general, building envelope, and system details sections. So we'll start with our location. So if you click change location, we will select the United States, and for this example, we will go to Atlanta. If you do not see your location, you can always click this Don't See Your Location button, and you can request a location to be added. If you do see your country, your best choice is probably to just select the closest city, as the weather data will not change very much between nearby cities. Once your location is set, you can see your weather data info by clicking the Show Data button there, and this will show you all of the populated weather data for your city. So any piece of information can be overridden. So for example, if we wanted to change our 99.6% dry bulb temperature value, we could change that by hitting override and entering a new value, and then hit close. If at any point you want to go back to the default values, you can just click the X and it will just return to whatever the value was for your location. So for this one, we'll just leave them all as the defaults and jump into the general information. So the general information starts with basic information about your house, and you can see that it's pre-populated with basic guesses about a typical house. So this is obviously not going to match your residential project, so we'll change them to match. You would change them to match whatever yours is. So for this example, we'll just use a few based on an imaginary house. So we'll say it's a 3-bedroom, and we'll say it's 2 stories, and we'll say it's about 1,200 square feet. So this example will be a house that's about 30 feet by 20 feet and 2 stories tall. Average ceiling height will go with 9, and the building volume would be about 600 times approximately 10 feet floor to floor is 6,000 times 2 is 12,000, so we'll go with 12,000. And then the indoor temperatures and humidities, these values look fine to me. We might even allow this summer humidity to go a little bit higher, but these values are okay. So we'll move on to the ventilation information. So for ventilation, you've got 2 options. You can either have the ventilation calculated automatically, or you can enter it manually. If you enter it manually, you just enter a straight value in CFM. But if you decide to have the calculations done automatically, then they are based on other inputs that are either already given or will be given at some point. For more information on how this works, you can open up your quick help and scroll down to the ventilation for recommendations. So you can see here it just uses the ASHRAE 62.2 calculations to come up with the value. And you can also click this more info drop down here to see how the calculations are actually being done. So in this case, it gives us the exact equation that's used to calculate the ventilation. So you can see it comes up with a value of 66 CFM, and that's based on floor area and the number of bedrooms. So for example, if you just were to change your floor area, let's go 1,500, you would see that the ventilation automatically changes to match our new inputs. So we'll go back to 1,200 for now. So for this example, I will go with the automatic. So for continuous exhaust, the next input, if you didn't know what this meant, we would just refer to the quick help pop-up on the right side here. And you can see that the continuous exhaust is intended for exhaust that is not related to combustion heating equipment or kitchen exhaust. So any exhaust that is intermittent should not be included in this. And that's the typical house, would not have any exhaust other than intermittent exhaust. For example, bathroom exhaust is turned on and then turned off after a certain time. So that would not be continuous. So we will select or enter 0 for this. It's quite uncommon that this would have a non-zero value, but in case it does, that option is there. The recovery type, this is to do with heat recovery. So you've got 2 options or 3 options. You can either have no heat recovery, or add an HRV or an ERV. The ERV has latent and sensible heat recovery, whereas the HRV has only sensible recovery. So for this one, I'll just select an HRV. Enter the flow and the summer and winter efficiency values. So for the flow, I'm just going to match the total ventilation. So we had 66 up there, and I will add 66 for the flow here. The efficiency values would come from the manufacturer's data. Since we don't have one selected here, I'm just going to make up some values that I think are pretty realistic for a small residential HRV. And then we have this other balanced airflows input. And again, this is not something that's is commonly known. So if we just refer to the quick help here, it describes what it actually is for us. And it's just any airflow entering the building mechanically that's balanced and is not considered ventilation. So it's not part of the HRV flow, it's not part of the ventilation, and it has to be balanced. This is a pretty uncommon situation as well, so we're just going to leave this as 0 for this example. And then we're going to move on to the infiltration here. So just like ventilation, the infiltration has the option to enter it manually or choose an automatic calculation. So if you were to enter manually, you would just give a direct CFM value for both summer and winter. Since we have no real way of knowing these values, I will just choose to have the calculation done automatically. So this requires a couple inputs. So first of all is the exposed building area. This is a little bit tough to know sometimes, but it comes from your architectural plans or can be pretty easily estimated. So in this example, I said we had a 20-foot by 30-foot building footprint, which gives us about 20 feet times 20-foot walls on two of the sides, and then the 30-foot by 20-foot walls on the other two sides. That'll be about 2,000 plus our roof area, so we'll call it about 2,600. The building construction quality, we have a few options here from a drop-down menu, so it's a little bit tough to know. But if we go to this table in our quick help, you can see a legend of how to assess these values. Average being typical house, loose being a bit of an older house. And for this, I think that good would be a good estimate. I think we'll just, I mean, it's an arbitrary selection for this example, but I think typical modern homes would be more on the good or the tight side. So the next input is the flue pipe effective leakage area. That's another one that's a little bit tough to know. But if we read this description here, this is to do with fuel burning appliances that have a flue pipe that's exiting the building, creating a penetration in the building. So for example, a 3-inch diameter gas furnace vent would have about 7 inches in effective leakage area. So we'll assume that this building does have a fuel burning appliance, and to avoid doing any calculations now, I will just give it we'll give it 7.07, which is exactly the value here in the example. Of course, if your house does not have any fuel burning appliances, you would just leave that as 0. If you had a different size flue pipe, you'd have to adjust the value accordingly. But for this example, we'll just go with 7.07. And you can see that with this automatic calculation, it tells us the output values right away. So we have 76 CFM in the winter and about 34 CFM in the summer. And if you look at the more info drop down, this one does not give the full calculations because they are a little bit involved here, but it does give a little bit more information about these inputs and outputs. So we will then move on to the internal gains, and this is the last of our general section. So internal gains are just the gains from people and appliances, machines, and lights inside the building. We again have an option to go with an automatic calculation or a manual entry. So if you go with a manual entry, you can enter the number of occupants and then additional sensible and latent loads in addition to the loads given off by the occupants. I will just go with automatic, and doing the automatic makes estimates about the number of people in the space as well as other typical values that come from the ASHRAE Fundamentals Handbook. And if we open our more info drop down again, you'll see how these calculations actually take place. So it's based on floor area and the number of people. The number of people is estimated based on the number of bedrooms. So for example, if we changed our general inputs again, what we would see is new values for our sensible and latent loads down here. They update automatically so that we can see exactly what we've got based on our previous inputs. So I will leave it for this example as the automatic calculations because I wouldn't otherwise know what values to input. And with that, we are done with all of the general inputs. So now that we're done the general inputs, we can move on to the building envelope inputs. This is the section that will take the longest amount of time because you're defining the exterior characteristics of your house. So you can see here we got walls, roofs, floors, and partitions. So we'll just go through these one at a time, starting with the walls. You can see here when we open up this drop-down menu, we have nothing here. We have to add a wall. So if we hit add wall, you'll see it starts a table for us. First we have the first column here is type, area, direction, mostly shaded, windows and doors, and then we have our edit and delete buttons. So on the type column here, you can see we have nothing selected yet. So if we hit select, you'll see we have no wall types created yet. So this is the wall type in terms of the construction of the wall or the characteristics of the wall. So we can hit create and create a wall from here. First thing you want to do is give it a name. So I'll call this one brick wall. We'll just say it's brick. And we have two options of how to build this. We can either build it by manually entering an R value, or we can build it by material. So I'll show you how to build it by material because this is a little bit more complicated, and entering it manually is quite simple. Most of the time you will know the R value, but in case you don't, this is a good option for estimating the R value. So you can hit the add layer button as many times as you'd like, and you can see here we have a few things. We got our material category and then the actual material type. So for example, let's say we have a plastering material on the outside of the wall. Actually, this is a brick wall, so we'll go with masonry materials, and we'll just go with brick low density. And you can see now that this thickness input has opened up for us. And so for some materials, the thickness is just a default, and you can't edit it, but for some of them, it's not default, and you have to give a thickness value to refine the R value. So we'll say it's about a 3-inch thick brick layer here, and then we will give it perhaps a wood layer. So we'll just make up some materials here, and then the most important part would be the insulation. So we'll give it some kind of insulation. Just go with this, and we'll say it's about a 6-inch stud, or maybe that's a bit big. Maybe we'll go with a 3-inch or a 4-inch stud, and then we will add some drywall like this. Maybe just say it's 1-inch thick, and we now have an R value of 18. So that's how we would just go through building a wall. You can see there's lots of different material categories and material types, and this allows you to have a lot of customization over your wall, but it can take more time to do it this way. But we'll leave it like this, and then the next piece is the solar absorbance value. Again, you can enter it manually, or you can select by material types. So you can see that we have a drop-down menu for different materials, and this is the solar absorption of that material. So for this one, we'll just go with the brick because we said it was a brick wall. So we'll select that, and now you can see that in this table of ours, our wall table, the wall type is brick wall, the one we just created. If at any point we wanted to change that, we can change it from here, or we can also go to our components section here, and under components we have the walls tab, and you can see that this brick wall is here in our walls tab because that's the one we just created. And we can go here and we can just edit the brick or edit the wall from this section. And if we edit it here, for example, if we changed our solar absorptance to concrete at 0.72, and then we go back to our build house tab and we click our brick wall, you can see it's now updated to what we just changed it to in our walls tab. And we can view the full list here, or we can go over here and we can view our full list, and we can duplicate the wall and change it. Let's say if we wanted to bump up our R value to let's say 25, then we could do that. And if we wanted to compare the two, we could run different simulations with different wall types. For this one, we'll just keep using our brick wall, and I will keep it at red brick for the absorptions value, and carry on. And you can see that we can keep adding walls as we like. So we'll add 4 walls, and we'll treat them, we'll say they're all the same wall type because it's pretty unlikely that we'll have different kinds of walls on our building, so we'll just leave them all as brick wall. But if you had different wall types, for example, if some were brick and some were stucco, you could very easily just change the wall type for some of them while keeping the other ones the same. So for each one, you have to enter an area. For this house, we'll say that it's a south-facing house, and that we have 4 walls, north, east, south, and west, just to keep it simple. So we'll say that the north and south walls are 30-foot by 20-foot walls, so they're 600 square feet. So we will just enter these details here. So we have our first one will actually be our south wall, and then we'll have our east wall, and then our north wall, and then our west wall. So these are the 4 walls that make up our house, and for each one we have to select yes or no for the mostly shaded column. And if you're unsure what that is, we can always refer to the quick help section, and it will tell you a little bit of information. So it says here for the mostly shaded input, if you're unsure, select no. And if it's things that are temporary in nature, like temporary structures, or perhaps even trees that might be cut down in the future, then it's best to just put no. If it's something like a large building next door that's permanent, that's causing it to be shaded most of the time, then you could put yes. But for this one, we'll just say no for all these inputs. And the next piece is to add windows and doors to each wall. So to add windows and doors, we just hit the edit button, and you can see we have options of adding windows and adding doors. So we will add a window here, and this looks very similar to the table when we added a wall. It first asks us to add a window type, give it a quantity, and then add an interior shading and an exterior shading. So currently we have no window types created. So if I hit select, it'll pop up a Windows list here, but you can see it's empty currently because we have not yet created a window. So I'll hit create, and we will give it a name. So maybe this one can be living room window. And then we start inputting the information for this window. So we'll say this is a pretty big one. This is the living room window, so it's about a 6-foot by 6-foot window. And you can enter the information for U value and solar heat gain coefficient manually, or you can build the specifications of the window. So this one's a little bit more complicated, but I will go with this for this example just to show you what it looks like. So you can select the number of panes first. So we'll go with 2. 2 is pretty common. 3 and 4 you'll almost never see except for certain high performance commercial buildings, so we'll leave it at 2. For the frame style, we'll say it's a wood frame. We can choose to use the default width for that frame, but let's say for this example we know the frame width. We'll just call it 2 inches. The glazing, so this is a coating that can be applied to the window. We'll say that it's a low E coating, so this helps with the performance. Panes applied to, this is getting a little bit overly detailed, and I will show you a little bit more information on that in a minute, but we'll leave it as is. We can add tint. You can see the only option here is clear, and that's because of the combination of inputs we've got above here. As you change inputs, the drop-down options change. So for example, if we went to surface 3, you can see now we have a bunch of different tint options. It is unlikely that we'll have a tinted window in a house, so I think we'll just leave it as clear. Pane thickness, we can go with a 1/4 inch or an 1/8 inch. I think we'll go with a 1/4. And then we can choose the type of gap. So we'll say it's a 1/2 inch argon gap for this. And then we'll hit select. And you can see that's now our window type. Now if we go to the Windows tab on the left here in our components, you can see we've got the window that we just created. And if we go here, you can see we have now our new custom quick help pop up here, and this tells us a little bit more information about what these inputs mean. So on this panes applied to, it says surface 2 or surface 3. If we didn't know what that meant, well, we can just refer here to this diagram, and it shows our inside surface and our outside surface. So the surface numbering starts counting from the outside. So you can see we have 1, 2, 3, and 4. So it's asking if the coating is applied on this surface or this surface. And that will affect a few things, including whether or not we can tint the window. That's getting a little bit overly complicated for most people, and that's usually not the level of detail that you'll need to enter, but in case you do, it's good to have that option and to know how to do it. So the next things are the interior shading and exterior shadings. So for those, similar process where we have to create them first. And I'll just go through the process here of what it looks like for interior shadings. So these are things like fabric curtains, louvered shades, and roller shades. Now it's recommended to not add these unless you're certain that it will be applied during peak load times. So for example, if your shades are on a timer to make sure that the sun is being blocked during certain times of the day, then it would be a good thing to add these. But if that's not the case, it's usually recommended to not include internal shading devices. So for this example, I will not include any, but they are there as an option. Then there's the external shadings. So these are things like barriers that will block sunlight from the windows. So for this house, we will add these, but it's important to remember that these are permanent fixtures and not temporary items, temporary like plants or some other kind of removable item that will not always be there. Because if it is removed in the future and the air conditioning unit is not able to keep up, then that's a bit of an issue. So this is things like structural overhangs that are built into the house that are not easy to remove, and the intent is to be there permanently. So we will create these, we're just not going to add them yet. This living room window will not have any of these devices, so we'll just leave it as it is. And then we will add a door as well. And the door will be the front door of the house. So this is a very identical process, so we'll go through it pretty quickly. You can see that we don't have any doors yet, so we'll create one. And we'll call it front door. It's important to give it a name. We'll just give it some basic dimensions that I'm just going to think of arbitrarily. The screen door, we'll say that this one doesn't have a screen door, but it's common that they will, and that will affect the thermal performance. The color we'll go with, maybe we'll go with dark for this one. And then the U value and the SHGC are entered manually as well, can be entered manually, or you can build the door from its specifications. You may be noticing here that we don't actually have an SHGC value, but we do have a percent glass value. And the reason we don't see an SHGC yet is because if we increase the percent glass above 0, we now have the SHGC value for the glass, and we also have a glass U value in addition to the non-glass U value. This is all a little bit complicated, and it's unlikely that you'll actually know these values, so sometimes it's easier to just build the door like this. So we'll say that it is a swinging door. You have the option of a sliding glass door as well, but for this one we'll say it's a swinging door. And wood slab and a wood frame is most likely to match what we've got here for a house, so we'll do that. And the percent glass, we'll say that it does have glass on it, so we'll say 40%, and we'll give it just a single pane of glass, and we'll say that it does have a thermal break. So this gives us an output U value and SHGC, and it's important to note that the SHGC value here only applies to the glass portion of this door. So 60% of this door is not glass, so it will not have this value applied to it. So we'll just hit select on this door. And of course, if we go to our doors tab on the left here, we can see the one we just created, and we can modify it if we like to. So we're done adding items to this south wall. So I'll just hit edit to close that, or you can hit this close button. We now have our east, north, and west walls. So we'll try to get through this a little bit quicker, but for the east wall, we'll add a couple of windows, but I'm not going to add the living room window. I'm going to create a new one, and we'll call this one bedroom window. It'll be a little bit smaller, let's say 4 by 3, and we'll say that this one is an operable window with a bug screen on the inside. The input type is, we'll go with build window again, so we'll just go with a 2-pane. Very similar specifications for this. We'll call it a 2-inch frame again, and we will just add the same gap type. I think it was 1/4 inch argon, and we'll hit select, and we will add 2 of these windows to this wall. We will not add any interior or exterior shadings here. So we'll go to the north wall, and we'll do something similar, and we will add just a 3rd window type here. We'll call it small window, and we'll say it's 3 by 2, and we'll just say this one is a fixed window. And again, we're going to add very similar specifications to this one. And then we'll hit select, and we will, for the purpose of demonstration, I will add an exterior shading to this one. We'll just call this shade 1, and we'll say that it's got a depth of 2 feet, and it is about 18 inches from the edge of the window. And we will give it a left fin as well. And of course, if those were not clear, if you were not clear on what those were, you can look at this diagram here in the quick help, and you'll see what the distance from parallel edge and the depth values actually mean. So you've got your left, right, and your horizontal fins. So we'll add 2 of these windows to our north wall, and we will actually add a door to our north wall as well, and this one will be our back door. So for the back door, I think we will make it a little bit bigger, because this one will be a sliding glass door. So if we hit build wall, or sorry, build door, we'll go with sliding glass door, and we will just add some specifications to this. And it's important to note that a sliding glass door is actually treated virtually identically to an operable window. So in this case, it is assuming it's basically 100% glass except for the frame area. So you can see we're adding very similar specifications that we added to our window. So we'll just go like that, and so now we have a glass door at the back of our house. And then for our west wall, we'll keep 2 of our bedroom windows on this one as well. And we won't add any shading devices to that. So we'll just hit close. And that is it for the walls. And now we can move on to the roofs. So the roofs section is basically identical to the walls section with a few minor exceptions. So I'll go through this pretty quick in the name of time here. So we can hit add roof the exact same way as you hit add wall, and of course we need to create a roof type. It's the exact same process as creating a wall. So I think for this time I'll just do manual input for the R value. So we'll just go with an arbitrary value of 35. And then for the solar absorptions, I'll just go with selecting material. So we'll go with some gray shingles and hit select. You can of course build it by material if you'd like as well, same as walls, but I'll just do manual for this one. The main difference here is this slope input. So the slope is, if you have a sloped roof, then the solar angles are of course going to be a little bit different. And if you go down here in your quick help, you can see a diagram of what this looks like and how to enter this input. So you can see here it's a percentage, which is different than an angle or anything. So this is how you would calculate your percentage, and it's important to enter it as a larger value, not as a 0.05, but as a 5% in this case, like it says in the quick help. So we'll say this one's about a 7% slope, so we'll do 7. And the area will be about 600, and the reason, or actually it'll be about 300. It's important to note that if you have the roof sloping in 2 different ways, like in this diagram here, if it at the halfway point changes directions, then it's important to add that as 2 different roofs. So in this case we'll have 2 roofs, both sloped at 7%. We'll say that one is towards the north and one is towards the south. The next input is for if it's adjacent to an attic or not. This will have a few impacts on later inputs. So we'll say yes for this one. We'll say that our house does have an attic. And then you can see here, instead of walls or instead of windows and doors, we have skylights. Skylights are created virtually identically to windows. So for this one, we'll just say it does not have any skylights. It's just easier that way. And you've seen the process is the exact same as windows, so we'll just not enter those here. But for skylights, those would be created in this tab on the left here. Created and edited and managed from that location. So with the roofs being done, we can move on to the floors. So for floors, you can add them continuously. For example, if you had a situation where you had a basement for part of the floor, but then it was a slab on grade for the other part, then you might want to add more than one, but usually you'll just have the one floor. So when you open up your floor details, you'll see that you've got a number of options here. So I won't go through all of the details of every option here. The information is all contained in your quick help descriptions. So I'll just go over the top 2 here because these are the 2 most common. And for the rest of it, you can read through your quick help if you need to, or just logic your way through the inputs. So we'll start with a slab on grade. This one's a little bit simpler, so you just first enter your area, which we would know from this one. Your outer wall construction, you'll see you've only got a few options here, and that's because just having a few options is quite a bit simpler, and there's not a huge difference between the different wall types if the wall types are very similar to each other. So it's just a few different major wall types for this. So we'll just go with the 4-inch block wall brick facing in this example. You can choose if it's insulated or uninsulated at the footing. So that's not wall insulation, that is floor insulation under the slab or with a structural footing that goes below the ground. If that's insulated, then you would select insulated for that. And then we have our exposed perimeter, and so we'll hit 100 for that. It's a 30 by 20 house, so we have 30, 20, 30, 20 is 100 feet. And then we can add a floor covering. So this would be things like carpet or pads or other or hardwood floors, things like that. So we'll just show a carpet. And what you can do here is you can open up your load preview drop down to show you what your loads are going to be before finalizing your decisions, which is it can be a good tool to make sure that everything checks out. So you can see with the slab on floor grade, we actually have no cooling load, so it won't affect that, but it does add a heating load, and it shows you here what the equation is that it uses to calculate that. So the other option being, or the other common option being slab below grade, which is a basement, and that's what we'll actually use for this example. So first input is the same, the area. We also have the same floor covering input, so that won't change. The more detailed inputs here are the depth, R value of floor insulation, R value of wall insulation, shortest width, and the below grade wall area. So we'll estimate a depth of about 6 feet. Since we had about 100 feet of perimeter, we know that it'll be about 600 feet of below grade wall area. So for the insulation values, you can see in this description here that bare concrete will actually already be built into this these calculations. So if you just had concrete floor and concrete walls with no other layers on them, then you would actually just enter 0 for these values here, because it's assumed that the construction already accounts for that. So if you had something like insulation or drywall or something added to your floor in addition to that concrete, that's what you would add here. So for the floor, we will assume it's got, let's say, R5 insulation, and for the walls, we'll say maybe R10 insulation, and then we can, we've got our carpet at the bottom here, which will add to the floor insulation, so it would end up being 5.6 in this case. The shortest width, this is to get a sense of the geometry of the building, and this will affect how the heat is transferred from the ground into the basement. So in this case, our shortest width would be 20, because it's a 20 by 30 basement. And then we have these last two inputs here for the ground surface temperature variation and the average ground temperature. So if we went with manual, you can see you can just change the value easily here. And if you went with manual on your ground temperature, you can edit it there, and you can always revert to your automatic, which will go back to your default value. And this, your quick help here, tells you where these values come from, which we won't go into right now, but if you want to go to your load preview again, you can see the effect of these of this type of floor. And again, we have no cooling load from the basement, we just have a heating load, and it gives the equations for how these things are calculated. So the last piece of our building envelope are the partitions. So partitions are walls that are separating your space from a partially conditioned or unconditioned space, but not separating your indoor from your indoor environment from the outside environment. So an exterior wall would be put into your walls section, but something like a wall separating your house from your garage would be put into the partitions. So I'll go through a quick example of a partition here. So when you add a partition, you can see you have to have a wall type that you add, a size, so let's say about 150 here, and then you have to add the associated buffer space. So the buffer space is the space that's on the other side of the wall. So in this case, we don't have any buffer spaces created yet. You can see that we have a location to make and manage our buffer spaces. So we'll go through the process of creating one here. And we'll say in this case that it is a garage. It won't always be. There's various types of buffer spaces that you can have partitions from, but this is a very common one for houses. So you can see we can enter details manually, or we can enter them automatically again. So if we enter them manually, we would just enter a winter and a summer temperature that we expect for this buffer space. So this is good, for example, if you knew that your space would be heated to a certain temperature in the winter. So for example, if you were going to heat it up to 50 degrees Fahrenheit in the winter and you just weren't going to cool it in the summer at all, then you might want to estimate your temperatures at 90 and 50. The 50 being a known value because you know that you're going to heat it to exactly 50. But if they're unheated or it's a little bit more unknown what the temperature will be, then you can use the build buffer space feature. So in this case, we just add a bunch of walls, all the walls that are bordering, that are creating the buffer space, that are the building envelope of this buffer space. So what we can do is add walls. So for example, if we had a brick wall, and then maybe we have this brick wall too, and then we had just some other mysterious wall that we don't really feel like making at the moment, we can just add it to our calculations as well. So what it does is it takes the R value of each wall, and if you have a manual one, you can just make up whatever R value you have for that wall. So we'll just say 12 for this example. You then give an area to each one. So we'll say this one is the 150, it's the same 150 as we have down there. And then we'll give 250 to each of these. And you then select your adjacent temperature. So is it adjacent to the outdoors, an indoor conditioned space like at your, the house that you're calculating, or some other temperature. So we'll say this one is adjacent to the indoors, this one's to the outdoor, and we'll just go with an other for this one. We'll say that it's adjacent to some space that's at about 60 in the winter, and let's say about 80 in the summer. And based on these, in this enclosure that we've defined for the buffer space, it estimates the winter and summer temperatures. We can also add a little bit of infiltration if we want, and that'll change our values a little bit. And we can add some heat generation as well. So in this case, I will actually just use the manual buffer space temperatures because I know that my garage will be heated to a very specific temperature. We'll have the thermostat set at that temperature, so it's more realistic to just enter it manually here. And we'll hit select, and we now have a partition from our house, which is the brick wall separating the house from the garage. And the final piece of our house inputs is the system details. So we have the first input is our primary location of duct runs. You can have the option of ducts are not being used or an unknown option. For this one, I will select the basement. I'll say that most of the ducts are in the basement, and this is really just for the losses from your duct, so heat losses or heating gains, depending on the season, from or to your ducts, and how it will affect your load. So it's good to check the results from this section afterwards to make sure that they are realistic and they're not overshooting your guesses. So for the leakage rate, we can just say it's unknown, or we can enter a value. If you look here at your quick help pop up here, you've got a table showing estimated leakage rates for different types of construction. And you can see here that for new construction, well-sealed and uninsulated duct and insulated ducts of high quality will still have some leakage, and it's estimated less than 5%. Sealant houses where no sealant is used that are in poor condition and there's noticeable leakage will have about 11% leakage or more. It's recommended not to go above this value because anything above this will just be adding huge loads to your system. So we recommend capping it at 11%. For this one, we'll say that it's a pretty new construction, so we'll go with about 6%. I think that's a fair guess. We then have the option of adding duct insulation. For this one, I will not add any duct insulation. And then the system type, is it a furnace or a heat pump? So in this case, we'll go with a furnace. And that's the end of our build house inputs. So if we go back to our guide, we can hit mark done, and we're ready to move on to the second piece of this of our process. So we can go to our results tab here on the left, and you see we have this big run calculations button. And before we do it, we have an option of selecting which heating and cooling design temperatures we want to use. We can go with this 99.6% or the 99% heating temperature. And for cooling, we can go for the 0.4%, the 1%, or the 2% temperature. So we'll go with the 1% for cooling and hit calculate. And you can see here we now have all of our load calculation outputs. So we have our summary at the top with our total cooling load, total cooling sensible load, and latent, our total heating load, the design temperatures that were used, and the total floor area. And if we scroll down here, you can see the breakdown of these loads, so you can see where all these numbers are coming from. So for our heating, we had 20,000 MBH, 10,000 was from the building envelope, about 7,000 was from outdoor air, and we had another 3,000 from distribution losses. This is one that's important to pay attention to because depending on the inputs you selected, for example, if we had put 11% for our leakage, this value might be very high, but it's important to make sure that it is a reasonable estimate. So 3,000 out of 20,000 I think is reasonable, so we're going to leave it like that. If we keep scrolling down, you'll see we have a pie chart showing the different aspects leading to our total sensible cooling load. A table showing these numbers, and it can be expanded a little bit further. For example, wall 2 window, wall 1 windows, wall 4 windows, and the relative percentage of the cooling load that they all make up. Same for heating loads. And then we have an input summary at the very bottom. And this input summary just shows us our basic house characteristics, environment, envelope details, and so on. So once you're satisfied with the load results, you can go back to the top of the page and you can download your results. So if you click download at the top here, it will allow you to save the PDF of your results. So we'll hit save. So once the PDF is saved to your computer, you can just open it up. You can share it, email it, do what you want with it. It's got the exact same information that's on the website. So you'll see like the summary table, the load breakdown table, input summary is all there. And then when back on the website, you can always modify your building and recalculate your results by just hitting recalculate. You can change your design temperatures as you want and re-download results as much as you like. So that's the full residential project tutorial for HeatWise. For more detailed subject matter specific content, we'll have other tutorial videos that dive deeper into all the particular areas of HeatWise, but for this is just the general overview for a residential project.